All right, hello everyone. Thanks for joining us for today's webinar. Empower devs, simplify ops, and accelerate your digital transformation. I'm just going to let everyone know a few things up top before we get started. One, we are recording. If you need to drop early or perhaps you have a colleague who is unable to join, you will be able to view this later on. Two, at the very, very end, when I close this out, a very short survey will come up just asking what you thought and what you would like to learn more about in the future. And lastly, you are able to ask questions as we go. So please, as soon as you think of one, even if maybe we'll get to it later on, go right ahead and ask it. It always helps us to know what everyone's looking to learn more about. To get started though, because I don't want to take up too much more time, I'd like to introduce a moderator for today, Sam Fell from CloudBees, to get us going. Sam.
Thank you, Max. Hey, everybody. Next slide, please, Anders. So we have a couple pretty well-known people on the docket today for this webinar who are pretty familiar with both the delivery side and the ops side. I'll start with our guest of honor, Damon Edwards. Damon, introduce yourself.
How you doing? I'm Damon Edwards. I'm the co-founders of Rundeck, and happy to be here and looking forward to this.
Wonderful. And I'm also joined by Anders Wallgren. Anders, introduce yourself.
Hi, I'm Anders Wallgren, but you knew that already. I'm a VP of Technology Strategy at CloudBees. As some of you may or may not know, I was, along with Sam, at Electric Cloud for many years, and we were acquired by CloudBees a few months ago, so we're now all bees and happy to be here today.
Big electric bees, exactly. All right, next slide, please. So the topic for today is we're talking about toil. And if you think about it, from development to operations, interrupt-driven work, failed deployments, these things erode productivity and reduce the time available to really innovate and add strategic value. And so today, Anders and Damon are going to have a discussion around ways that you can today implement to help deliver software services more efficiently without that toil, use self-service to avoid death by 1,000 service desk tickets, and eliminate variance and drift in your software delivery while increasing security and uptime. And so we're going to be talking about that in the concept of either a sort of a day one activity, which is getting the software to market, or day two activity of sort of operating that software and making sure that the environment that it runs in stays available. So next slide, please. And at this point, I'm going to hand it off to Damon to tell us first, before we get into this too much, what the definition of toil is.
Yeah, just to kind of provide some context as to how I even ended up on this this webinar with Anders. We were talking about this idea of toil, which has come from the SRE movement, and I'll kind of explain what it is in a minute if you aren't already cheating and reading ahead on the screen here. But how it's really came from the operations side of the house, but how it applies also to the development side of the house. So that's kind of why we decided to get together and do this webinar. And if you want to start with the definition of toil, I think Google, Vivek Rao in particular, did a great job of defining what toil is. And toil is really a name for a problem that we've always felt, right? It's, I'm just going to read off the screen here. Toil is the kind of work tied to running a production service that tends to be manual, repetitive, automatable, right? Meaning that it's the kind of thing we could automate, right? It's a thing we do by hand often. Maybe it's hand coordinating a bunch of scripts, but still a manual, human intervention process. It's repetitive, it's automatable, it's tactical, and it's devoid of enduring value, which is probably the real key statement there, right? That it may be necessary, it might be the kind of thing that we have to do to keep the business going, but it's not adding value. It's not moving the business forward. It's just we're kind of running in place, right? And it scales linearly as the service grows, which is an important indicator, meaning that if we have 1,000 users today and we have 1 million users tomorrow, how many more people would we have to add to our system to keep it running? Well, that's a sign that there's toil in the system, right? That it can't scale on its own. We have to, as humans, intervene to keep things running. So I'm going to go to the next screen there, Anders. So what's the opposite of toil? Like if we're looking at toil as a problem, what's the positive, right? And that's really engineering work, right? So kind of have these two lists of attributes here that kind of help describe the difference between toil and engineering work. First of all, toil, as I said, it lacks enduring value, right? Again, it may be important, may have to do it on a day-to-day basis to keep the business running, but we're not moving things forward, right? Versus engineering work is about building value, right? Makes tomorrow better than today. Toil tends to be rote and repetitive. It's the kind of thing we do over and over again. Whereas engineering work is more the creative and iterative, right? We have to kind of rethink it and build on itself each time we do it. Toil tends to be tactical. Engineering work tends to be strategic. Toil increases with scale, right? It's an idea that we go from 1,000 to 1,000,000 users. How many more people do we have to add? That's a sign there's toil somewhere there in the system. Whereas engineering work enables scaling. It's the kind of thing we do in order to launch and enable that scaling. And importantly, toil can be automated. Probably should be automated. It's the stuff that computers are good at and computers can do. Versus engineering work, which really is about requiring that human creativity. It's that our assets, the things that we spend, the people we spend the money on. How do we use their human creativity instead of having them do things that machines should be doing? So as we go to the next slide here, why does this really matter, right? Because what's engineering work good for, right? Engineering work is, if you imagine this is like a balance, like a sliding scale here. Engineering work can be used for two things. Number one, improving the business, right? We can actually make tomorrow better than today, and reducing toil, right? So it's what we use to figure out how are we going to get rid of this manual, repetitive, busy work that we keep doing. And by the way, engineering work does not have to be, I'm going to sit down and open up an IDE and start writing code. There's all kinds of ways to, engineer and script and kind of, change the process that is adding value. So don't think this has to be hardcore programming. Working with the YAML files can be just as much engineering work as writing code. So, there's just two things you can do, right? You can reduce toil, you can improve the business. But if you let that toil get away from you, if you let it start to crowd out that engineering work, you have two major problems. One is you have no capacity to improve the business. That's not good. But worse, you have no capacity to reduce toil. You're stuck, right? That's when you're spinning in place, and this downward spiral starts to happen. So it's very important to keep that balance between the toil and the engineering work. Because we want to avoid the downward spiral, as I mentioned. Let's keep going here. Let's keep going here.
I sort of like to call that the tractor pull problem. If you've ever seen the mechanics of a tractor pull, where you watch the weight move closer and closer to the kingpin of the tractor, where at that point, when it is over the kingpin of the tractor, you bog down, you don't move anymore. That is kind of the syndrome that you get into if you're not able to deal with the toil that you have. You will eventually grind to a halt.
Yeah, that's a very good way to look at it, right?
Back to the shift left sort of mentality is if you have problems that are going to hit you later, solve them early so that you're not going to run into them. And so that seems to be very much in line with what getting rid of that toil is.
Yeah, and this feeling of everyone's busy, nothing's getting done, right? That's another sign of there's a lot of toil in the system, right? Everybody's going 100 miles an hour, and it's a lot of busy work. It's a lot of moving. It's a lot of motion. It's a lot of moving things around. But if you think about it, it's like, hey, how much of your day was actually spent doing things that are really moving things forward? It's like, it's kind of a small amount, right? Because we're buried in all the other work. It's like, well, how do we get unburied from all that other work? Well, we need time to engineer our way out of it, to redefine the process, to change, to improve the system, which is really this kind of the point of this slide here. Niall Murphy from now at Microsoft Azure made this great point that about toil really being a naturally recurring force. And he talks about it as there's this general evolution of automation, right? So whenever you produce a system or produce a new service, there's always going to be either things you don't know or things you did not have enough time to do, right? Maybe there's some kind of database maintenance or tuning that has to happen. We didn't really think about it ahead of time. Or maybe it's things like we didn't have enough time to add the admin console, right? To add users or to add partners or things like that to the system. So there's no automation in place for those things. Step one, we just have to do it manually, right? And then we figure out, okay, well, hey, let's figure out some externally maintained system-specific automation. Fancy way for saying I've got my script for it, right? I wrote a script for it. I've got it. I'm the one who takes care of the system. I just know in my home directory is a script. Then we say, okay, well, let's have some generic automation. Let's tell everybody, hey, in this directory, you will find a script for this particular, task. And then it's like, okay, well, let's kind of maintain that internally. Let's maybe have an Ansible playbook or a Python script, or something that says we're going to distribute it with that thing, right? We're going to, as we release a new version of it in this directory, there's going to be this script you can call to do this. And then finally, we're at a point where, hey, why don't we just build that into the system? Why don't we build the database maintenance or task into the application? Or why don't we add a screen that allows admins to the business admins to do whatever they have to do, right? So if you kind of go forward here, so what happens? It starts a lot of toil at the beginning, and then we start to kind of move the toil out of the system, but nothing stands still, right? So we're constantly relaunching new systems, constantly going through the cycle of launch, a lot of to-dos and a lot of unknowns, to where it gets more mature, and then we start all over again. So it's a naturally recurring force that happens time and time again. So we'll never fully get rid of toil. This is the kind of thing where we have to build an organization that has the mindset of, let's go and constantly find ways to eliminate this toil. So we go forward here. Yeah, so this is where kind of Anders and I conversation started to merge, which is, hey, toil really kind of got its rise or got its notoriety from the SRE movement, looking at operations work, but it's not just an operations concern. So Anders, you want to talk about what we had discussed?
Yeah, absolutely. I mean, if we think of this as sort of, day one, day two, you obviously want to play in your garden like a pro and weed it and keep it taken over. But then, if you stop paying attention to it, pretty soon you're going to be, covered in weeds, and that's not a good thing. And if we think about this sort of in terms of day one development, because before you run some product, you actually have to produce and create the product. And so, here's sort of the dev remix of Vivek's, definition of toil. We're really talking here about, the kind of work tied to delivering a production service and having it scale linearly as the application complexity grows. Really that applies just as well while you're engineering a product as when you're running a product. And a lot of the same things apply. We did a small survey as part of an effort with Forrester a number of years ago. And when I say small, I mean, small enough that it's not even in the ballpark when it comes to being scientifically valid. But it was a very simple one. It was a very simple question that we posed to a number of people. Developers and testers were the audience for that survey. And the question was simply, how many hours a week do you spend waiting on stuff? Waiting on stuff to happen on your behalf? And the numbers were kind of frightening. Developers said, in a week I spend about 10 hours waiting for things, waiting for builds, waiting for tests, waiting for environments, sitting in meetings, those sorts of things. I don't think sitting in meetings was actually something that they defined as slow and painful, although some of us might. It was even worse on the testing side, on the QE side. There was more like 18 hours. Again, scientific survey, but I don't think that a lot of us would go, oh, no frickin' way. There's never been a week where I don't spend that much time waiting on stuff to happen. So one of the kinds of toil that we have in engineering is waiting for stuff, which is, that's sort of an interesting counterintuitive notion of toil, which is usually associated with doing stuff. In this case, it's really waiting for other people to do stuff. And I'll talk a little bit about, how we can fix that. But what are other things that create toil in dev, right? Having lack of shared visibility across dev, QA, and ops, right? Across the, and for that matter, back into the business or forward into, customer success and those sorts of things. If, one of the most dreaded experiences for a lot of engineering managers is getting asked to do a presentation on, hey, where are we? What's the state of the world? Because inevitably that involves a lot of work, a lot of going through different systems, looking at this stat, that stat, generating this report, that report, instead of just sort of pointing to an existing, product or report that just kind of tells you, hey, where are we? What's the state of the world for this delivery pipeline, for that delivery pipeline? And similarly to an ops, in dev, there are just as many, if not more, manually operated, non-integrated tool chains, right? And we have the same, kind of game that gets played there in terms of, am I going to do this frequently enough, that I want to automate this? And, most of the time, the first time you do something manually, you kind of go, I'll just do it manually this time because, well, if I don't do it manually once, I probably don't even know how to automate it, right? So I'll go off and do that. And then the second and subsequent times that you start to have to do things manually, you start to kind of go down that path that Damon described in terms of, first I have my script, and then I get something to execute my script, and then, maybe we even go beyond there. And of course, if you've got distributed teams and distributed locations, and if you work in a company that has, let's say grown through acquisition and mergers, then you've got all kinds of different processes and tools, and this notion that across a big enterprise that you just choose the best of breed tools and roll them out to everyone is, at least in my experience, a complete fantasy, right? Because every enterprise that's out there of any size has at least 2 of every single tool under the sun. And so it's difficult to standardize. It's difficult to do those kinds of things. And when you have a lot of different tool chains and a lot of different processes, that makes it difficult to create leverageable automation. Because if I have 10 different tool chains across 10 different products and I automate one tool chain, well, I still have 9 to do. Now, does that mean that we should just put our foot down and say thou shalt use the same tool chain across all 10 product lines? No, that probably isn't a realistic solution, but something to think about in terms of where you go forward and how you adopt new tool chains and leave old ones behind, because that's another challenge that enterprises run into, is they generally never retire technologies, they just acquire new ones. And then in general, we're also often dealing with brittle, error-prone, non-scalable, non-shareable home-built systems, or and they may not be home-built. They may in fact be brittle, error-prone, non-scalable, non-shareable commercial systems or open source systems, right? But they take care in feeding and nurturing, and that is toil. If somebody installs the wrong plugin into your CI system and it takes your CI system down for a day, somebody has to go fix that. That's downtime, that's recovery time, and that is toil. And it makes it very difficult to roll up and get any sort of auditability and traceability across these things, because if they're disparate systems, you got to go do that manually, right? There's no way that you're going to get a consistent picture across the entire life cycle, across the entire pipeline or pipelines, as to, hey, where am I spending my time? Where am I doing manual work? Where am I spending time waiting on manual operations? Where am I spending time waiting on automatic operations? Those kinds of things. And the same sorts of issues, again, as in ops, where we don't have repeatability, we don't have predictability, we're wasting time and money dealing with errors, and generally this is more of a problem with running things in production than for dev, but less and less so low infrastructure utilization. As engineering organizations have started to rely more on virtualization and containerization and Kuberneticization, if that's a word, I guess it is now. Making sure that infrastructure is being being wisely used, so you can start to answer the simple questions of, what build is in QA, what build is in dev, what build is in production. Has this feature and this bug fix gone into production? Sorry, I missed that, Sam. Please say again.
I said it rolls right off the tongue. Kuberneticization. I think it's perfect.
And it's interesting because all these things you're talking about, they may not be classically considered like toil. Like they're like, oh, toil was in sort of the operation side. But if you do the litmus test here, right? Is it manual? Yep. Is it repetitive? Yep. You do it over and over again. Is it automatable? Well, sure. Even the waiting, it's like we could automate this away. We could put a self-service into place. We could, put the right, the right dashboards into place to make it so you don't have to ask somebody a question, or you don't have to go to them to do something for you. So it is automatable. It's tactical. It's the stuff we got to do on a day-to-day basis. It's not moving anything forwards. There's no enduring value. It's not adding to our, we're not producing something that's going to help us tomorrow. It's just stuff we have to do today to get things done. And it grows with the service, right? Meaning that like the more we produce, or the more we're building here, the more we have to do this. So it actually fits perfectly into the definition of toil, even though most people don't think of it as toil because it's not a bunch of operations tasks.
Yeah, I think a phrase I hear quite a lot is developer productivity, right, or engineering team productivity, and that's really sort of a different way of saying getting rid of toil on the engineering side, and smart large organizations have resources dedicated to nothing but making sure the developers are productive and
that's right.
Interrupted.
Yeah, and but it's interesting. It's kind of like I think the problem is the definition of what productive means has gotten away from people, right? It's like sometimes we replace productive with busy, right? I think that's the great thing about toil is it gives you a very clear definition and a very clear point of view for an organization to say it's not about how busy we are, it's about how productive we are, right? And how much
busy,
right? How much engineering work are we getting done versus how much of our life is toil, right? And I think that's the real test of productivity is how much is getting done. Not that hey, everybody's working 10 hours a day. That's fantastic, right? We're all working 100% 10 hours a day, so 6 days a week. We must be really crushing it, right? That doesn't work out.
That goes right to the kind of the success of the organization in terms of the value that you're able to deliver to customers, but also to just employee satisfaction. And do I feel like I'm wasting my time? Do I feel like I'm being productive, right? So kind of transitioning a little bit. So how do we start reducing kind of that kind of toil? One of the most important things that we've seen, across the years, and admittedly, we work with and sell products that do this, but it's self-service for everything, right? Self-service for environment provisioning, and if you're the CFO, you're very concerned about this deprovisioning, making sure that resources are getting recycled. Are we able to do that? And that kind of goes back to that simple survey that we did a number of years ago. A lot of the time that people would spend waiting would be waiting for environments. Hey, I need an environment to do a test. I need an environment to do a regression test. I need an environment to do scalability testing. We need to deploy the latest version so that it's available to people. And a lot of this comes down to a couple of things. One is, if you're working on a product, then the notion of deployment should not be reserved exclusively for when you go into production, right? And I think nowadays this is less of an aha moment for people than it was, say, 5 years ago. But your first deployment of your product should not be into production, right? It should be that your development engineers are deploying for their own use, and then if you're doing sort of if you have a QA organization that then kind of takes over from there and does a little bit of sort of dedicated testing, are they able to self-service deploy a particular version of the application? And things like, here's another kind of waiting / toil, which is, am I waiting for an environment because there's only one? Kind of the singleton problem, right? And there's lots of organizations out there still today where they have only the one test environment, whether it's for development testing or QA testing or further on down the line. Now, of course, once you get down to the production environment, there you kind of have the one, but there's no reason in development or during testing why there should only be one environment. And so if you have the ability to automate setting up environments, you now have the ability to do development testing, QE testing, all of those kinds of things in parallel. And we still see quite often in the enterprises out there that, oh, well, we had to wait 3 days because we couldn't get access to the test environment, the test environment. And one of the easiest ways, not simple, but one of the easiest ways to get out of this is to, automate the ability to stand up these environments, automate the ability, have the ability to have multiple of them, and then make it self-service, right? I tell a story about how one of our customers this is many, many years ago, so it's a little bit of an old story, but I think the point holds, where, their SLA back in the days of hardware, when an engineering organization needed a new piece of hardware, was 6 weeks from the time you requested it to when it was rack stacked, had power, had network, had the OS, all that sort of stuff. That organization then, of course, and this tells you how many years ago this is, went completely virtual and switched over to using virtual machines. Their SLA for when an engineering organization requested a new system to when they delivered it was still 6 weeks. So even though they now had the ability to automate and had the ability to stand something up in minutes, because there was no physical work required, there was no acquisition work required, no purchasing required, they still didn't, kind of step back and kind of fix the SLAs to the point where, even though I can provide this for you in 15 minutes, I still have 6 weeks to do it in, right? And really the next step beyond that is self-service, right? That's really key. Another thing that we see all the time is sort of versioning, right? Versioning your binaries. Obviously, I think nearly all of us these days are versioning our source code. Very many of us, although not all and not a high enough percentages, is also versioning our binaries, having artifact repositories for those kinds of things. I think as you go in, as we go down the road of, loosely coupled microservices and breaking up our monoliths and so on, those kinds of things, repositories, binary repositories, registries for containers, those kinds of things become much more important, right? And a lot of this, again, has to do with wait states. One of the most valuable things of breaking up monoliths is I no longer have to wait for everybody to get ready so that we can jump over the line at the same time, right? As soon as my service is ready, it goes, and I move on to the next thing, right? I don't have to find busy work for myself while I wait for the other 4 teams to get their part of the monolith ready so that we can all, jump over the line. And really thinking about your pipeline, your software delivery pipeline, your commit all the way through to production pipeline. Take an engineering approach to that. Treat that as a very important feature of your product, right? If you think about the kinds of folks that you want to have working on your pipeline, that's not a job that you give to your intern that's coming out of high school, right? This is really the pipeline is an important enough thing that you really want to have, kind of dedicated, good, important, skilled, experienced resources on this kind of thing. May not be a full-time job, right? But it's definitely not something. Well, in some cases, it definitely is a full-time job. But it's not something that you just throw at the intern for 2 weeks and then all of a sudden, boom, you've got your fully automated pipeline where I can deploy. I can request tests and I can set up environments and all of those kinds of things. A nice side effect, by the way, of where you get to the point where you've got this pipeline automation and orchestration going is that a lot of the work that you have to do if you're in the kind of industry where this matters around governance and auditability, you get almost for free as a side effect of automation, right? When did we deploy? What did we deploy? What build stack did that come out of? What change lists were included? What epics were pulled in as a side effect of that? Who gave the approval for that? All of those kinds of things are a lot easier to gather and cause a lot less toil once you've automated your pipeline, right? And we've had examples of where engineering organizations in aerospace, for example, would literally after a 2 or 3 week sprint would spend a whole entire week doing nothing but auditing on what they just did so that they could produce the reports that were necessary in order to satisfy the governance and auditability things. Once they automated their pipeline, that literally settled down to them for like a 1 or 2 hour activity that they did post-sprint, and they were immediately able to kind of get up and do productive work again, as opposed to having this sort of downtime period where they went back and figured out what they did so that they could then do the audit part of that. Shift left on security, that just is a that's a no-brainer these days, is to treat security as a feature. Performance and scalability, I think, goes in that same bucket in terms of these are not things that you want to think of as things that you sprinkle on the plate right before you serve it to your customer in the restaurant. It's not a plating activity, as they would call it in a restaurant, right? These are things that you have to build in from the beginning. You can't just say, all right, now we've built our entire product, now let's make it secure, or we built our entire product, or we built this entire new feature or capability, now let's make it secure, now let's make it fast, now let's make it scale, all of those kinds of things. These things like quality itself are things that you have to build in from the beginning. And again, giving people visibility into all the appropriate aspects of this, and the pipeline is a big deal, a big part of that. Those kinds of things really start to take the wait states and a lot of the toil out of the engineering organizations. And really, how do we know this? And this is, from a logical fallacy perspective, yes, this is absolutely an appeal to authority. But there's some science behind this authority, right? So if you start to, if you go through the DevOps handbook, if you read the State of DevOps report, all of these kinds of great resources that we have out there, there's a lot of evidence that shows that these things work. There's a lot of evidence that shows that the pain that we go through in a lot of organizations, it's not necessary. There's better ways to do it. And there is an investment necessary, right? You will have to go slower in order to go faster. At some point, right? Or you will have to dedicate more resources to something for a little while to get past that, right? It is an investment. Getting rid of toil is an investment, but it is an important investment. As Damon, pointed out in his slides, you eventually get to the point where you don't even have enough work capacity to deal with the new toil that's coming online, and things grind to a halt. The tractor pull. You get to the point where you no longer make progress. So there's a lot of data out there, and if you do nothing else, go read the DevOps handbook. That'll teach you a lot about good things. And don't mean for this to be a commercial for the book, but it is a great resource for learning these things.
So
I'm going to flip back. Yeah, sorry, go ahead.
Yeah, no, I was just about to say, so that's really interesting to think about how this toil definition sort of affects folks on the dev side. And this webinar is empowering dev and simplifying ops. And so interested to get into the day 2 stuff. I wanted to mention that Jorn had another idea for Kubernetified, he says is the correct.
Okay.
So that
I can buy that.
Yep. So we've got people with great that he's weighing in as well.
We'll see which one shows up in the OED first, but I'm happy with either one.
Yeah. All right.
So switching, kind of switching gears back a little bit to you, Damon, here on kind of the day 2 aspects of, okay, fine, we built a product, built some capability. How do we start reducing toil on that?
Sure, and before we even get to that, I want to kind of do the list of things. If you go back to your list, like the one before the DevOps, the handbook one. There's interesting. I've seen this interesting kind of, I guess maybe it's a causal loop between the pipelines and the test environment problem. And it's all started with kind of a curious. I heard a couple folks say this to me, like, well, they have all these problems because their test environments, like they have problems with standing, don't have the right standing data, they don't have the right mock services, they don't have the right scale. It's not the same kind of OS versions or underlying platforms that are running in development. It's not the same as production. So they got all these kind of all these problems come up from that, and then you find out, well, why don't you have more test environments? And they're like, oh, well, we had more, but they were too hard to manage, right? So they actually reduced the number of test environments because they're too difficult to manage. Well, why are they too difficult to manage? Well, because we didn't have all of the automation in place, the pipelines to build the environments as code, the whole stack, right? From the and say, hey, I want this, and this, and spin me up a full environment like that to test it. And it's like, well, why isn't that done? It's like, well, we know we have to do it, but we don't have time. Why? Well, because we're chasing all these problems in the environment, in this, in these few QA environments we have that keep getting slammed, from all there's collisions from all the different people trying to use them. So it's a very interesting kind of, and a good example of like, we're too busy to do the one thing that we know will help us with the thing we're too busy with today, right?
I like to call that too busy drowning to learn how to swim.
Exactly. So it's a very interesting how these things all kind of interplay with each other. Okay, well, let's go forward to what I was going to talk about. So we're talking about on the operation side. I think this is got a pretty well. There's a lot of prior art behind this, but it's pretty basic to how you start reducing toil. Number one, you got to track the toil levels for each team, right? Meaning that it doesn't really necessarily have to be a time tracking type scenario. That's probably the least effective way to do it. But generally, how I've seen most people do it well is they use their existing project management Scrum Master, type function. They do a quick survey inside the team, and just to find out, hey, on any given week per se, right, or any given particular period of time, how much of our time is spent on what we would classify as toil, what we would classify as engineering work. And it's important really to set the definition. That is probably the most important part. So things like meetings, right? Meetings or doing your expense report, right? That's probably overhead, right? It's probably not actual toil because it's not actually doing your job, right? That's not what you're hired to do. That's just kind of overhead. So it is kind of a waste in theory, but we probably don't want to track that as toil. We'll probably track that as something else. But again, the idea is not to have time tracking per se, but the idea is to be able to say, hey, look, for any given period of time, what is the balance between toil and engineering work for a particular team, right? And then we want to set some kind of official limit, right? The kind of conventional wisdom out there today is 50%, right? To say that, all right, we want to have, this is actually the way this number came from Google. They got people followed it too, to say, hey, we want to have at least 50%, at least on the operation side, 50% of their time is doing engineering work to make tomorrow better than today, and 50% is this interrupt-driven toil or this kind of repetitive busy work that we have to do, and that's okay. That means we're kind of in balance, and that's the limit we want to set. Now, what happens if you go over that? Well, you need to have some way to, you got to fund the effort to reduce the toil. So when these teams get out of balance, you want emphasis on those teams that are over that limit and say, how can we help them? How can we swarm to them and dig them out from underneath this? Because effectively, we have to look at it as we're just wasting money. We're taking that team's capacity and we're just lighting it on fire. And it's our most expensive, part of our company is our people. It's the most valuable part of our company is our people. We have to free them up to use the brains that we hired them to do. There's a great presentation here that Michael Keogh and Todd Polino did at SRECon recently about this program that LinkedIn has called Code Yellow. And Code Yellow, which I do believe actually in the kind of U.S. hospital system is also the code for impending disaster, right? So when the hurricane's about to hit, they call a Code Yellow in a hospital. So I think the idea here is that we got to have an official program, right? Because we just say, oh, look at that, they're buried in toil, that's terrible. But everyone's going to get busy doing doing other things, and then that team's just going to keep drowning. So, having an official program to say, hey, this team, for whatever circumstances, has found itself buried in this toil. Let's get an official program together to help them get out from underneath that toil, whether that's more headcount or lightening up on the project work we put their way. Who knows what it is? That's for for everyone else to figure out. But it's very important that you have an official way to say, this is what toil means to us. This is the limit we're going to have, and then here's the program that we can use to help the folks that find themselves buried under toil.
I think there's an interesting kind of corollary too, and out of other aspects of SRE around, what SRE calls the error budget, right? And if you exceed your error budget, that means you need to pull back on your pace a little bit. And I think that a little bit of a corollary here too, in terms of, look, if you are spending more than 50% or X% on toil, you need to fund efforts to reduce that. Part of that funding, you need to pull back a little bit sometimes, right? Because sometimes you're trying to go too fast, and you're under engineering your process and your systems a little bit when that happens.
Yeah, and so I think what's the magic sauce of SRE? So people look at the top level stuff like, oh, operations folks that get to do more development type work, and look at these, they kind of associate with cool new tools like observability and different automation tools. But the reality is, it's underneath it. It's SRE is really about self-regulation, right? It's about how do you let development operations, regulate the relationship between them. So, the error budget is an example of that. It's saying that, hey, we're going to have this service level objective, and above that is basically budget. So if we only need 95% response rate for something, right, or uptime even, right, then hey, everything above that 5%, that 5% is budget. Let's use it on other things, right? If the business has agreed it's not going to improve outcomes be above that, then why are we trying to get to 99 and 5 nines? Why don't we figure out how do we use that 5% to move the business forward? But it also knows that if we get close to or dip below that 95%, then we all have to swarm to it, development, operations, product, and figure out how do we get back above that line. So it kind of gives a self-regulating mechanism. And same way here with toil limits, right? We're saying that, hey, these teams, we can't bury our teams in all of this non-value adding work. We have to have a way to signal when things are going well or when they're going poorly. And that's the idea of this toil limit, is it sets that that self-regulating mechanism to when we know when the flag goes up, we got to go and do something about it. So where to focus? There's kind of 3 areas, right? The first is reducing technical debt. Okay. The second is re-engineering processes. You'd be surprised how much, if you just change who does what, when, and where, kind of rethink how work flows in the organization. There's a lot of toil you can get rid of. And the last one is enabling self-service. So the first 2, reducing technical debt, re-engineering the process. I can't tell you much advice about that. You really have to go into your organization, step through it piece by piece, and figure out where the value can come from. That's very specific to you. But this idea of enabling self-service, that is something that definitely I could talk to. So let's talk about that. So, this idea here that in operations especially, we're full of all these functional silos, right? Or functional teams, right? We got the the Linux team, the Windows admin team, we've got the storage team, the database team, the core networking team, the firewall team, so on and so on and so on, right? Everybody's kind of aligned by these functional groupings. And what ends up happening is work doesn't live in any of those silos. It's kind of passed through all those different functional silos to get things done, right? So what ends up happening is someone's always saying, hey, I need you to do X for me, right? And at that point, they're now waiting. And what you're generally doing is injecting some kind of interruption into somebody else who gets distracted from the things that they're supposed to be working on. Chances are it's not the main thing they're supposed to be working on, so they're going to be dropping what they're doing, kind of doing something manual, something semi-manual. It's kind of an expensive way to keep working. And as we go forward here, you'll see that the idea here is that, hey, how do we replace all that waiting and all those interruptions with automated self-service, right? With the ability for somebody to say, instead of saying, I need you to do X for me, I'm going to go to some self-service interface and do X for myself, right? And by doing that, we're interrupting the interruptions, we're interrupting the waiting, and we're going to be injecting or causing, I guess, sparking a whole lot less toil throughout the organization. So, how do you get rid of this, right? How do you get rid of all of this interruptions and waiting and this kind of disconnected ways of working that causes all these problems at the at the seams? A big part of it is really empowering these teams to spot and fix those anti-patterns for themselves, right? Empower them with the tooling and the process and really the enablement to say, hey, go ahead and fix these things as they arise. Give them a little bit of capacity. Again, an important reason why you want to have the right balance between toil and engineering work, but give them the capacity to go and start to solve these problems themselves. I'll just run through some kind of classic examples here, right? The first one is the repetitive requests, right? The pure toil stuff, right? Hey, fix this for me, fix it again, then fix it again, then fix it again. And you're interjecting more waiting, more interruptions to the system. You're distracting people from doing the other things that they have to do. What you can do about that is encourage people to, in all those little kind of micro instances, look for ways to create self-service, right? To say, hey, well, let's take the existing scripts and tools you have to do. Let's turn them into kind of an automated workflow that somebody can go and run for themselves. Of course, there's a whole lot of security and operational concerns around that. You have to pick the right tooling to do it, but it can be done. Another one, I could fix it, but I can't get to it. How many times this happened, right? Which is, I know what I have to do. It's just over there in that environment, but I can't get to that environment. Maybe it's got customer data in it. Maybe just some, there's political reasons for it. It can be any kind of, from, political management concerns all the way over to audit and compliance concerns. I could do it, but I just can't get to it. So, what you want to do instead is, that's a good way to use the self-service to say, hey, let's give people, access to specific named procedures, right? So instead of saying, hey, here's your SSH key and your sudo privileges and the restart script, have fun in production, right? It's more like saying, hey, I'm going to give you this specific button to push that says, hey, go ahead and, restart, service X in this production environment. Make sure it has the right options that I can pass in there. It has the right error handling notifications. But now I can tell security, compliance, whoever, say, look, I'm not giving people free reign access or things that are hard to audit. I'm giving them access to a very specific named procedure. And we've learned time and time again that compliance goes for that because that's actually better controls. They actually know who actually ran what and who built it and where it ran. Unlike the old model, which is I give you some kind of break glass access, you go in there, you do some stuff, you come back and self-report on what you did. This way, we don't have to go through all that. We can give people specific access to specific procedures.
And as we've seen sort of in the world of, kind of shadow IT, people will figure out how to end run the system, right? So work is getting done even if you're not allowing or making it easy for people to do it. I don't mean from a security perspective necessarily, but a lot of times you'll just ask your buddy to do it for you who has access. And now it's done, it's happened, it's worked, but you have very little record of it, no accounting for it, no auditability for it. So, again, self-service is incredibly powerful on a lot of dimensions, not just in terms of getting it done, but getting it done safely and in a way that's auditable and governable.
Well, what's funny about the security controls is you think about a lot of the, people use their ITSM tools or ticket tools to have this great workflow, right? This great feeder of approvals and, visibility and whatnot. And then it finally comes down to the person that's going to go do the work. And they go in to log into a system, do some stuff, and they turn around and write done, right? So we totally lost all control and visibility of what's actually transpired, right? And so now we have to collapse down the number of people who can do things to a very small group that we can background check and keep our eyes on and really kind of sit on top of. Instead of what we want to do is distribute control via those specific lockdown name procedures to as broad of audiences as possible.
And when it's done in those sorts of manual, ad hoc, fragmented fashions, you also lose the insight into how long it's taking to do certain things. Because if I do the thing and then I run out and get lunch and then I come back and I say I'm done, it looks like it took 90 minutes to do something, and people might say, well, that's a 90-minute task. Well, no, it was a 30-minute task. I just forgot to send the email for an hour, right? So it, having it all kind of in the system gives you better data to then do some analysis on it and decide where you're spending your time.
Yeah, this is a fun one. So the dog pile, this is an operations favorite, which is like, oh, we're on the bridge call, right? Jump on the bridge call, and someone goes, oh, there's a problem with this particular database instance, right? And so like, what do? You go and you log into that instance and you run top, and the first 10 things you see are your 10 other colleagues on the call running top, right? So you just get that dog pile, that collision. That's not very useful, and it's actually worse when people start doing things and not knowing what somebody else is doing, or hey, Anders, try this, and you tried the red version, I wanted you to try the green version, and neither of us is none the wiser, and we you create all kinds of problems, right? So by kind of going through that consistent self-service, we're giving people a place to look, right? We can say, I'm going to run this now, let me Slack you the output of this, and or a link to watch it run, right? So another kind of smart use of self-service is to keep the the triage situations out of these dogpile scenarios.
Yep. And top is probably best case scenario in terms of it's relatively inexpensive to run. It's not unheard of that you get 5 people logging in and they're all running a fine / something and are chewing through the disks very quickly, and everything grinds to a halt.
Exactly.
In addition to not solving the problem.
Exactly. Another favorite here, right? I'm an expert. I'll read the wiki, right? So, hey, how many times I've restarted the service, right? A lot of times, right? But, unbeknownst to me is that, hey, the service has changed. Everything's changing fast now, right? They're like, hey, you must use this new flag, right? And provide this particular value, or or bad things are gonna happen, right? Or, the knock is like, hey, come on now, every time you restart this service, we run around for 20 minutes. Thinking that the world's ending, and it turns out that it's just you restarting the service, right? So where they put that? Oh, they put it in the wiki, right? Well, what happens at 3 in the morning when that person that's always that's done this time and time again for the last couple of years, right? What are they going to do? Are they going to read the wiki? Of course not, right? They're just going to roll out of bed and they're going to do the same way they've always done it. Didn't quiet the monitoring, didn't use the right flag, chaos ensues, right? Versus kind of with the self-service models, we're talking about executable code here, right? So we're getting people to say, hey, this is our automated run book. Here's how we're gonna do things. If you want to add a step to quiet the monitoring, add a step to quiet the monitoring, right? If you need to add a flag, just change whatever restart script or command you're using in that workflow, and that happens. The expert rolls out of bed at 3 in the morning, still not gonna check the wiki, but now when they run that same consistent command, they've all the expertise that came from their colleagues has all been encapsulated in that procedure.
And that's, it's difficult to scale without these sorts of pieces of functionality, right? Because you're gonna be killing people every morning at 3 a.m. with these kinds of problems. They're not going to have the bandwidth, the brain cycles to be able to solve these, the really hard problems, the one where they do have to get woken up at 3 a.m. And start to dig into something that's new and fresh, and not just, hey, we got to restart the service to apply a patch or something like that.
Right. And having this be an engineering-driven effort, engineering with the idea, Anders, you talked about version control and checking things in, with the idea of having sort of the standard run book or the standard process by which these things are done, allowing an engineering approach to incrementally improve them, to adapt to changing situations, to apply them in an abstract way across multiple different domains, if that's possible. These are all things that can help reduce that toil. It, of course, introduces some different kind of toil because you have to then maintain all these scripts, but maintaining something that helps you alleviate a lot of work is maybe better than just doing the work manually all the time.
And in theory, that would be engineering work, right? So, I mean, if you do it properly, yeah, if you always have, say if you have to, like, every time you go to do something, you got to go to some text file somewhere and you have to update the list of nodes that you're going to run some, that script against. Yeah, I think that I'd call that toil, right? But if you're just going in there to refine the process or to add more air checking or to, kind of look for look for some air conditions, right? Maybe run a diagnostic before and after. I would consider that engineering work, because then you're actually adding value, right? You're protecting the company, you're protecting your colleagues, you're making it easier for a broader number of your colleagues to take that action because it's safer, right? So I'd put that in the engineering bucket.
I agree, and I think one of the other important aspects of that too is it makes you a more scalable and learning organization, right? Because you're at that point, instead of just the wiki, it's the executable wiki. Put it that way, right?
Yeah, and that's kind of how we've, runbook automation. The idea is kind of a classic term that was around in the 90s and 2000s, and then it's really kind of made a comeback, sort of actually via the SRE movement. A lot of talk of runbooks, because it's the realization that you can't just do everything from a config management repo, right? There's a lot of operational activity that has to happen. There's a lot of human to tool interaction that has to happen when you're operating complex systems, and that's both for diagnosing problems and repairing, and repairing the service, right? So the idea from our perspective of runbook automation is it's safe access to the expert knowledge you need to solve your problem, right? So that's a big problem here, is like, well, I just know I'm the one that knows how to use, let's use a restart for an example, right? Is the restart automated, right? Sam, you're asking me, right? And I'm like, yeah, sure, it's automated. And you're like, okay, well, let me run it, right? And I'm like, well, first you got to know how to go into Nagios and quiet the monitoring. Then you got to know how to go into F5 and drain the traffic off of that particular instance of the service. And then you got to know how to go and make sure the traffic is actually off. And then you go and you run your restart script. And then there's 5 or 6 things that you got to go and check to make sure is this service actually back up again, right? Or sometimes things get stuck or whatever. And then once I've done those 5 or 6 kind of things by hand, then I go back into the F5, put it back in the load balancer pool, put traffic back on it, and then I go to Nagios. It's like, okay, well, how am I going to hand that off to you, right? Like, there's all these little different systems and tools that I have this knowledge for, and if I'm going to now create all of that together, like, whew, that seems like a whole programming effort, right? That's hard. So the idea is, if you have a common kind of workflow system, you can go in there and say, let's create, that runbook automation that will then give people access to that specialized knowledge that you have in your head, and do it through executable, an executable job, right? And then I can put guardrails around that. I could say, hey, here's the different option parameters that you can or can't provide, and I can say allowed values, stuff that I want to constrain people's input. And then I want to add note of air handling, right? Some extra checking in there. Do this recovery step if something fails. That's all the kind of stuff that people can focus on, and is the idea of kind of building, runbook automations, that safe access to the expert knowledge.
And a lot of that has to do with, as you sort of described there, kind of restarting the service, but, you got to do this, and this. A lot of that is sort of discovering the work that's required to be done to do it, right?
Yeah.
And terminology, even words just get in our ways. And I have this anecdote that I still tell of, we were working with a prospect, and we asked them, so are you scripting your deployments? Oh, yes, they're completely 100% scripted. What they meant by that, and this was, imprecision in our question, was they meant script in the Hollywood sense, not script in the programming sense. So they had a Word document that had, step by step what was supposed to happen. So that was their definition of it's scripted, right? So a lot of times when you ask someone, is it automated? Yes. Well, can I do it myself? That's a great question to ask, right? Because at that point, you now start to discover all the things that are not really part of the automation, or all the definitions that are being used in slightly different ways than you would expect them to.
Yeah, that's exactly. I think I got one more of these, which is this one's pure toil, right? Which is, often it's like there is some problem, right? And there's a problem in production, and development's just not going to fix it. Right, it's a known issue. We've raised it, bug closed, and often it's because of we haven't had the chance to get to it, or it's just too monumental of a problem that we're going to have to rebuild the system or something like that. Whatever the reason is, it's just going to be there, right? And so how are we going to quickly know that, yeah, that's the problem we're seeing again, right? And fix it, right? And because of that, we're constantly, how many, talk to operations organizations, how much of their work is just repetitive known issues? Like, we know this problem is going to happen, or we know some flavor of this problem is going to happen, and we know how to fix it, but we're time and time again, we're going through the motions to get, to resolve that. And, this is really where kind of the self-service idea comes into the runbook automation idea can really help you stave off that toil, in that it's no longer, okay, every time this happens, escalate up the chain, the third person up the chain that knows the magic incantations will come and do that. Well, number one, it's pure toil, because it's just rote, repetitive, should have been automated work that we're pushing onto that person or interrupting them from their strategic, kind of engineering work that they're doing. But we can, with self-service, we can head that off, right? We can say, hey, here's the automated runbook. Somebody who first sees that problem, whether it's a knock type situation or like an on-call, for a particular team, they've got that ability to hit a button to say, oh, yep, ran the different scripts or tests that we know to check and see if it's the same problem. Looks like the same problem, run the fix, whatever that is, a restart or, clearing a cache or, whatever it might be. And, then we move on, right? So it's not ideal, but this is kind of the fact of life in the enterprises. There's not enough budget and time to go around to fix everything.
Yeah, I mean, we live in a world of trade-offs. We don't live in a world of infinite resources. So, you often do find yourself in a scenario where, you're going to be living with that workaround for a while. So the easier and less expensive and less weight statey you can make the workaround, and the more automated and self-service you can make it, then the better. Now, the flip side of that is you might be living with that workaround forever if you do that, but that's still well, yeah, you have to go through the manual steps every time. So I'll take that.
Right, exactly. It's better to live with that problem than it is. I mean, that's just that's a different problem to solve. But yeah, it's better to do that than it is, to have that problem and keep injecting toil into everybody's life.
Exactly.
So this has been amazing. This has been great conversation and great information. We have a lot of questions that people have been asking. I don't think we're going to be able to get to all of them because we have 1 minute left. I do want to ask one of the questions, though, that has come up. Should we try to standardize day 1 and day 2 tooling and processes, or should each team have their own? And so I'll throw that question out to both of you.
I mean, to me, there's 2 levels, right? There's kind of the tool chain architecture, which I think should be consistent. Like, this is a package repository. A package repository is not the G drive. A package repository has metadata and has security and has an API and blah blah blah, right? Like, so if we have that kind of definition around this is kind of how things need to hang together. I think at least on the operation side, at the implementation level, you can have some variety, right? So if that team loves Ansible, that team loves pure Python. This team over here was Chef, right? Those folks, they're in the Windows world. They're all PowerShell, right? And then we got these other 9 teams. They love Bash and Perl and everything else, right? Well, at the underlying level, it shouldn't matter, right? It's okay for them to use the tools that they want to use, as long as at the higher level, there's a tool chain architecture in place where that kind of elemental automation can hang together. So therefore, I can hand it off to other people, right? I can say, if you hit this, button, it's going to run all the necessary steps. You don't have to care what those steps are underneath the covers, whether they're a pure HTTP, call to a REST API, or it's running some bash script, should be irrelevant to your colleagues to collaborate around you. So from an ops perspective, I think focus on the toolchain architecture, allow flexibility at the lower levels so teams can be productive, get things done, do what they have to do. But the key thing is it's got to all easily hang together.
Yeah, and I think the same applies on the dev side. I mean, I think, it also depends on the organization that you work in, right? I mean, obviously, if you're a company and you buy another company, now you're going to have 2 sets of tool chains, most likely, or at least somewhat divergent tool chains. And it's it is a trade-off to decide, how much effort do I want to spend on rationalizing that so that we can all have exactly the same versus, maybe what I ought to do is pay attention to outcomes, right? And if both teams are achieving good outcomes with the tooling that they're using, then maybe we don't focus on that so much, or maybe we pick the one that is causing pain downstream, or those kinds of things. I think you have to have a rational approach to it. I think I've seen scenarios where, there's sort of a dictate from above of thou shalt use or thou shalt not use. And those sorts of things, they generally run into problems, right? I mean, it's better for those things to be able to evolve a little bit organically and then allow them to change over time. But you also have to temper that against, you really don't want to be in the scenario where 5 years later you have 2 of everything. So you do have to do a little bit of spring cleaning every once in a while to stay happy, or things do get out of control.
Lovely. Well, we are past the top of the hour. I want to thank both Damon and Anders for joining us for this webinar, and I will hand it back to you, Max, to close us out.
All right, thanks, Sam. Thanks, Damon. Thanks, Anders. Thanks, everyone, for watching. Before we sign off, just a real quick reminder, a very short 4-question survey is going to pop up asking what you thought and what you'd like to learn more about. If the answer to what you'd like to learn more about is just another session like this, let us know, whatever it may be. Damon and Anders, before we go, any quick final words you'd like to include?
I would just say, hey, thanks for listening to us talk about this, and thanks to everyone for joining.
Excellent. All right.
Thanks, everyone.
Thanks, everybody. Bye.
Thank you. Bye.